Welcome back to episode 42 in our programming series. Today we're going to talk about what's known as recursion. So anyways, recursion is basically when we have this function and we call itself within itself. So you can see that over there. Anyways, before we move on to a specific example, we need to talk about what the call stack is. So the call stack is basically a structure that we can keep track of what's currently being executed and what still needs to be finished executing. So let's take an example program. And a call stack is created for every program that's running on our computer. So anyways, if you have a Chrome tab open and you have like, I don't know, Visual Studio open, there's going to be a call stack for each one of those programs. So let's take a example here. Say in this program we have our main function, and within the main function we call a function called func, and within the func function we're just printing hello to the screen. So what's going to happen is when we actually double click on the exe to run it, the main function is going to be invoked and the operating system is going to pass control over to the main over the CPU so that I can execute. And then once it calls the func function, the main is going to pass control over the CPUs to the func function. Now it's going to print to the screen and then it's going to finish. So it's going to be cleared off the call stack and transfer control back over to the main. So anyways, once the main finishes, obviously the program is done. So now the control of the CPUs is transferred back over to the operating system. So that's how the call stack works. Whatever's on the top of the call stack is the function currently being executed, and what's directly below it is the function where it came from, where it was called. So anyways, we're going to use that in recursion. Here's a pretty famous example of recursion that most people start with. It's called factorializing. If you don't know what factorializing is, it's when we take a positive integer and multiply by every positive integer under it. So for example, if we want to factorialize 5, in math they just say 5 and then an exclamation mark. This would just be equal to 5 times 4 times 3 times 2 times 1. So we're going to create a function that recursively does this. So first we need to start with the function declaration. We're going to call it factorialize. We're going to pass in our original number and call it x, and then we're going to return an integer as our return value. So now to actually define this function, we're going to have two cases, a case known as the base case and then a case known as the recursive case. So anyways, what the base case does is, as I was mentioning, we just go from function to function, and what's going to happen with the base case is it's going to stop recursively calling and start backtracing through the functions. That's what the base case is there for. So anyways, the other case is the recursive case, and that's the case where we're actually recursively calling the same function and creating a new frame on the call stack. So yeah, the actual case is, you can see what they're doing. If x is equal to 1, that's our base case. Then we're just going to return 1, because if you think about it, if you try to factorialize 1, it's just 1, because 1 is the lowest positive integer. Anyways, that's our base case. Now our recursive case is if x is equal to anything else, and you can see what we're doing is returning x times the function factorialize with the parameter x minus 1. So this is probably one of the most important parts of recursion. You have to pass in a parameter that's different than your current parameter. So if you don't do this, what's going to happen is your parameter is never going to change, and you're not going to hit your base case unless you pass in 1. So what's going to happen is you're going to keep calling this function over and over and over until you run out of memory or you close the program by yourself. And obviously that's not a good thing. So we need to make sure that we hit the base case by passing in a different parameter. So now that we actually have seen what this base case does and what the recursive case does, let's go ahead and see an example. So let's say we want to factorialize the number 3. We're going to pass in 3 from our main function into this factorialize function. So first off, when we start the program, again, the main is going to get control of the CPUs from the operating system. And then when we call factorialize, we're going to pass in 3. So I'm going to say I'll just say fact and then the number, so 3. So now this has control, and obviously 3 is not equal to 1, so we have to take the recursive case. So now from this function here, we're going to return x times, well, actually x would just be 3, so I'll just write that. We're going to return 3 times whatever this next function gets us. So we're recursively calling the factorialize function with x minus 1. So 3 minus 1 is 2. So now this is currently being executed, and it's given control from that function. And anyways, 2 is not equal to 1, so we haven't hit our base case, so we have to recursively call again. And again, we're returning from this function 2 times whatever the next function gives us. So we create another frame and we transfer control over to factorialize of x minus 1, which is 1. Now you can see we've hit our base case because 1 is equal to 1. So we're just returning the number 1. So now we do 2 times 1, and then we return that over to that function. And first off, this would be cleared off the call stack like that. And then this one too would be cleared off the call stack because we have its return value now, 2 times 1. And then it's returned over to 3. So now we do 3 times 2. Or you can think about it as like 3 times 2 times 1, like that. And then we return that over to the main function. And this factorialized 3 is cleared off the stack, and we're done. And we have our answer in the main, and we can use it. And 3 times 2 times 1 is 6. And then once our program finishes here, the main is cleared off, our program is done, and the control is passed back to the operating system. So that's what recursion is. Thank you for watching. Catch you later.
Perfect.